question 14b. Here we've got a ball of mass 2 kilograms. It is thrown vertically downwards at a speed of 15 meters per second towards the ground from a height of 2.8 meters. The ball hits the ground and rebounds at a speed of 12 meters per second, as shown in figure 14.1. We're going to assume that there's no air resistance acting on the ball. And part I is going to ask us to calculate the speed of the ball just before it hits the ground. Okay, so because there's no air resistance, we've got no drag forces, so the acceleration will be constant. And if we've got a constant acceleration, that means we can use our Suvat equations. So let's decide which one we're going to do. So we know it's going to fall a distance of 2.8 meters. Initially it has a velocity of 15 meters per second. There. We want to know what the final velocity is going to be just before it hits the ground, and we would assume that it's on the Earth, so it would have an acceleration of 9.81 meters per second squared. And we don't know anything about the time. So, going to our formula sheets, we want to find a formula that doesn't have time, so that will give us v squared equals u squared plus 2as. And if we now substitute our values in for that, so v squared is going to equal u squared, which is 15 squared, plus 2 times 9.81 times 2.8. And if we then take the square root of all of that, that will tell us our final velocity. So put that into your calculator and you should come out with an answer of 17 meters per second.